Hello everyone. My name is Manmeet Singh. I'm from Advanced Engineers, your own system integration company with a focus on energy efficiency and automation. Today's video presentation is going to cover primarily the application of level measurement in your tank kitchen. So, if you are a company who is more into LPG marketing, you are into a company who is using LPG, or if you are a company who is looking for a solution to measure inventory for your LPG tanks, this presentation is for you. So, as I said, this is a video which has been created for Bharat Petroleum Corporation Limited. It's their LPG group. What they have asked is they have asked us to bring a proposal together where we can offer them suitable level gauges, suitable pressure gauges, temperature gauges with a combination of all the devices so that they can have a complete inventory management system along with their tank farm management system. So this whole exercise is being done by Bharat Petroleum to make sure that the kind of the inventory they are using or the kind of the inventory they are having in their plants is accounted for, and there is a centralized server to know that what kind of the product they are having and what kind of product they have sold on this. So this whole process which I'm going to take you through is actually going to help you to decide on the suitable gauges for your LPG storage vessels. Now, the background of this is that all the LPG plants which are in the country in India are mostly having three types of the storage vessels. One is the Horton spheres. So they have got Horton spheres, they have got the mounted bullets and the above ground bullets. There are three types of storage vessels are there. And it depends on the time of the installation plant. There are also possibility you can have a combination of all the three also or the combination of the two also. So that depends on that. All these LPG vessels also need to be monitored round the clock for particularly about the LPG quantity they are holding, what kind of the temperatures is there in the vessel, what kind of pressures are in the vessels. These are also to be monitored. These are the OSD requirements which need to be done, and the LPG quantity is requirement of the inventory management. The type of the level gauges that are available here for the LPG is, I'll just put this shadow here. So type of the level gauges for the LPG are servo gauges, radar gauges, Rochester gauges, guided wave radar gauges, and non-invasive level gauges. So these are the major technologies. Then there is one more technology called the magnetic gauges are also there. DP gauges are all there. The dip gauges are also there. There are different gauges, but here I'm covering all these main gauges, which are basically nowadays de facto standards nowadays being used, and all the new vessels which are coming are also having the same type of gauges. So first, I am going to explain about the servo level gauge. As you can see from the picture also, the servo level gauge is having one small float. It's electromechanical device. So what it does is it's basically has got a float on the top and then there is a motor. So motor suspends that float into the vessel, and in the vessel whenever there is a liquid is there, then the float touches. So it's a buoyancy principle. So as the buoyancy goes, the float starts floating on the liquid. So basically, what is happening is the wire is being it's hanging from the top, and the tension is being maintained. As soon as the float touches the liquid level, automatically the tension gets reduced. So the servo gauge, if you see on the top, the servo gauge is basically this kind of mechanism where you have a motor also, then you have got a calibration, then you have a valve and a steel well. So this is a float. So on the center part is a float. This float is actually floating on the liquid itself. So automatically it gets suspended from the top. It goes to the liquid, and from the liquid there is a change in the tension because the liquid buoyancy supports that float. So automatically there is a change in the tension, and as soon as there is a change in the tension, the electronics measures the tension, and based on that it gives you the travel time. There is the travel of the particular wire which is there. So based on that wire travel, it calculates that this much is the level. It's a pretty simple device. I would say this was installed almost 50 or 60 years ago for the liquid measurement. At that time, they were used to having the mechanical registers. Then slowly the electronics came. They started to put in electronics to show displays also, and those displays are brought into the control room also. Now you can have all the communication also coming up. So this is a basic device where the servo, why it's called servo, there is a motor on that, that's a servo motor, which actually regulates the movement of this float. And as the float goes down, it actually calculates how many circles it has cut, and based on that, there is an encoder, small encoder is there, and gives you an output. So this is the simple working of servo gauges. And I'm sure if you are into LPG, you must be having uh, witnessed the operation of servo level gauge in some of your plants. The main benefits of his, it's rugged and tested, because as I said, more than 50 years, it's a very very long time. So more than 50 years this instrument is being used in the industry. People are fascinated with this particular technology because it's rugged and it's tested. It's highly accurate because it's actually touching the liquid. So once it is touching the liquid, that's the best way of measuring it, because it's a direct measurement of that liquid, and it's reliable also because it has been working for the last so many years. So you will see most of the LPG officers will say servo level gauge is the most accurate product available in the market, and I would say yes, they are right based on that. Now, these are the pictures. If you see, this is the on the left side. There is the technician who is actually maintaining that servo gauge. So on the bottom there is a wall. On there, this is a calibration chamber, and then we have got a servo motor over here, where you have a small dial also. On the right picture, you will see we have actually blown out proportion of the complete electronics, how it is going to work. So there is a motor, there are some gearboxes, so there is a pulley also. So what happens is here also the float is actually going down, and is then it is again also pulled up also for the maintenance activity. You do that. So it's a complex machine. Although it's very accurate, it is working very fine, but it's a complex machine. So this is what we have for the servo gauge. The challenges for the servo gauge are also listed here. The first is it's bulky and heavy. If you see the previous picture, the height of the gauge assembly itself is bigger than the man. So it's a minimum requirement, and average assembly is weighing minimum 500 kgs to 700 kgs. So bringing it on the top of the vessel is also a big challenge, and putting it on the top of the vessel is also a big challenge, because on the top of the vessel you need to have all the structural support and everything, and the vessel should also be designed to handle these kind of the loads. So if the initial vessels, definitely it's easy, because in the initial vessel when they are installed, they are also installed with all the accessories and everything. So the load bearing capacity of the vessel is also being calculated. But if it's an old vessel, you are using an existing vessel where you want to install a servo level gauge, it's always recommended that you get the structural analysis done, so that the load calculation of the servo gauge, because it's not a servo gauge, you will need a steel well also into this. So the weight is going to be maybe more than 1.5 tons for the complete thing. So your vessel should also be able to withstand that much of pressure and that much of the weight on itself without any damage to it. So first is the bulky and heavy weight. Second is the its electromechanicals. As I've shown, there is the motor inside. So when the motor moves, there is a pulley and the pulley. So all these electromechanical products, they need maintenance. You need the greasing, you need the calibration, the wear and tear is also there. The friction also plays its part. So slowly, slowly, you will see there is a challenge in the maintenance. So if we are maintaining our servo gauges regular basis, they are the perfect gauges. But the challenge here is you need to have a dedicated team to maintain it. You need to have regular spares replacement. You need to have regular calibration being done. You need to check the floats, because the floats also get punctured because of pressure or something. Because float is a very light float because of the LPG density. You need to have a very light float. So all those things. It's a maintenance prone activity which you need to be very careful about that. It's complicated to repair because there are maybe hundreds of the components in that, you never know which is going to fail. It's not a small instrument, it's a big instrument. It is having so many things in: motors, pulleys, gears, sensors, hall effect sensors, PCBs, electronics, so many things. So anything can go bad. So anything, if it goes bad, it's very difficult to find out what is the problem, how we can find it out, where is the issue. That is the issue. Next, and the biggest point over here is it needs minimum 6 inches nozzle on the top, because that is something which is mandatory, because you need to create a float which can actually float on the LPG. So the float design has to be as such that it floats on the LPG. So traditionally we have been using minimum 6 inches float. So nowadays we have brought the sizes of those 6 inches to 4.5 inches, but still the size of the float is quite bigger because it has to float. So we create a surface area so that it floats on the LPG, because LPG density is way too low. Now, all technologies apart, it needs one nozzle from the top so that the float goes inside. It's the minimum requirement, because until unless you don't have a nozzle on the top, you will not be able to bring in the float. Now, this float is also hanging with a very small, very thin wire. That wire also snaps sometimes, because if you are not able, because it's LPG, you are blind on it. So during a maintenance procedure, what you do is you give command to the servo gauge to pull the float up onto the top, And when you pull the float onto the top, it's not a guaranteed that the float has reached on the top. So sometimes what happens, it gets stuck in between in the wall or somewhere in the chamber itself. Now what happens is then you have to close the ball wall. Once you close that ball wall is a mechanical device and you need some strength to move it. As soon as you close it, that wire gets snapped and the float goes to the bottom of the liquid. So that is what happens. So you need minimum 6 inches nozzle on the top. Without that, the servo gauge cannot be installed. Now, LPG, when there is a filling of the tank, it's always from the bottom. So there you will see there are a lot of bubbling coming up on the top. So there is a lot of bubbles, or you can say the turbulence on the top. Now, because of the turbulence, you will see the liquid moving on this, and especially if these are the bullets, and especially above ground bullets or the mounted bullets, you can see the liquid moving from left to right or the front to the back. So the way depending on the inlet is being done. So what happens is the float also floats along with this. So suppose float is on the center, and as soon as the filling starts and the liquid starts flowing to the other side, the float also goes over there. To avoid that kind of thing, what we do is we put a still well. So we put a pipe, a standard pipe which has got holes in it, so that it's only carrying the liquid. And even if the liquid is moving, it's turbulent outside, the float remains inside. The float never goes out of that particular. So you need to have a still well. SS still well of that particular height has to be installed inside that particular 6 inches nozzle, because the float has to stay inside. It cannot wander off. So that is one minimum requirement in a servo you have to put in. Then you need to put a calibration chamber also, because as I said, it's an electromechanical device. There is a wear and tear happening. The sensors are also getting old. Then there is also a possibility of change in the tension also because of the change in the weight of the float itself, or it gets corroded also. So there are many things which happen. So what you do is you need to have a calibration chamber on the top, so you can actually see what is the movement of the float physically. So once you see that, so you can calibrate the electronics over there. So you need a calibration chamber also. Now, to do all this, to put a 6 inches nozzle on the top, to put a still well inside the tank, you and put a calibration, which is basically the loaded calibration chamber on the top, which is going to add up to the weight of the particular structure. You need to go for a vessel modification. Either you have to put for a support structure, you have to go for a top crown modification, anything like that you may have to, will incur a PESO approval. So you need to degas the product, your tank. You need to go for a PESO approval. And nowadays, after the COVID, we have seen the PESO approvals are taking too much time. Our experience says average PESO approval comes from PESO at least 2 to 3 months. That is the basic time they take. And then the approvals for doing the job at site and all that, plus taking a shutdown if you are having a 3 bullets. Example, if you are having a 3 bullets and you want all the modification for two to one on the 3 bullets, you cannot give it to me for modification every day. So we have to schedule 1 month, 1 bullet, second month, second bullet, then third one. That way we can do it. It will take minimum 1 year for the complete process to be done if it is done streamlined and religiously. You never know what is going to happen. My experience, in a year you are able to do only 2 vessels in a single location. Otherwise, if you are trying to do more, there are a lot of challenges which we face. So we normally recommend not to go for any kind of vessel modification until it's damn necessary. So that's my. So if you see, the servo gauges are going to be a poor choice for above ground bullets, because above ground bullets are a small size bullet where the dia is not more than 3.5 meters. They are already installed on a particular structure which are open to the atmosphere, where the corrosion of the structure and everything has already happened. They also have on the top, they have got some kind of a structure to for the people to maintain and walk and all that stuff. Now on the particular structure, you are also putting up 1.5 tons of the servo gauge and assembly over there, and the steel well also there. So you need to go for a structural analysis. So normally for above ground bullets, the kind of the cost that you are going to incur, which is in the form of the material supply, which is in the form of the shutdown, non-availability of your bullets, is going to be very, very high. So it's not recommended to go in for a servo gauge on the bullets. But it's your choice. If you want to buy a servo level gauge, they are definitely possible. We can do that. They are highly accurate gauges, and you can do. This was my opinion. You can have your own call also. Now coming to next type of the gauges is radar level gauges, because radar is something which is the in thing nowadays, because all kind of the issues that we have faced in the past are because of the electromechanical challenges. So electromechanical challenges, what they are doing is, because of the motor, because of all those things, what is going to happen is the wear and tear is going to happen, and that wear and tear is actually causing the issue in the measurement. And here, radars don't have any wear and tear because there is nothing which is moving. So these are non-contact. If you see in the picture, there is a small antenna which is actually sending some radar waves. So they are non-contact microwaves. They go from the top, they go to the liquid. From the liquid, they again get reflected back to, and they are being received by the sensor. So it's a same sensor is emitting the waves and it is actually receiving the waves. So both it is being done here. What it does is it actually calculates the time of flight, how much time these waves have taken to come back from the liquid surface. Simple. So we calibrate the radar first of all in zero level. So whenever there is no liquid inside the tank, and then there is the maximum liquid. That is one way of doing it. Second way is you already have the drawings of your vessel. So once you have the drawings of the vessel, we know at what height this radar has been installed, because radar is actually calculated not the level, but it is actually calculating the distance. So it actually can measure the distance, how far is the liquid from here, because you must have seen all the radars, specifically if you see the airplane radars also and the sonars also, they do same thing. They send in the waves and the waves are returned back. They calculate what is the distance. So here also it is the same. It is actually calculated the distance, but we are in the electronics, we are programming it because we know the maximum distance. Maximum distance is a zero level. So we actually recalibrate on the opposite side and we give you what is the level. So it's the same thing. And radar level gauges will give you something accuracy of 1 mm. So that is the highest accuracy available as of now for the instrumentation. So they are available. And radar gauges don't have any moving parts. So you don't have any pulleys, you don't have any motors, you don't have any kind of what do you say, gearboxes or anything like that. No float, nothing. So they are relatively better placed in today's technology as compared to servo gauges for installation. Here I am putting up some benefits for radar level gauges. First of all, the first benefit of radar level gauges, there are no moving parts. So in the servo gauge, as we said, there are moving parts, so many things are going on. So there here we don't have any moving parts. Then we have got a small form factor. That is very, very important because a radar maximum, including the flange size, because the flange itself is going to have a weight. Our radar has got a weight of not more than 1 kgs, but since it has to be installed with a flange, so depending on flange, whether you are having a flange of 2 inches or you are having a flange of 6 inches, the flange, class cylinder flange, the weight actually adds. So maximum weight cannot be more than 5 kgs. This is what we have observed, and a single person can actually take it to the top of the vessel and install it. Imagine what do you need for servo gauge, because servo gauge you need a big lift or a chain pulley block where you can actually bring everything onto the top and then install it. So it's very cumbersome. Radar is very, very easy to be brought in. Uh, you can use it. It's highly accurate because now the technology is different. Now the radars come with a frequency of 80 gigahertz. The conventional radars, which were the old radars, which were having issues in the accuracy, were actually 10 gigahertz. So it was a differentiator because 80 gigahertz is it's a high frequency. The high amount of the data is coming back. So that is the difference. So 10 gigahertz, imagine the data which goes and the data which comes back is lesser. Here we have got 80 gigahertz, the higher energy and higher data is coming. So we are able to give you accuracy of 1 mm. So 1 mm accuracy is good enough. If you check with your calibration charts in your vessels, your calibration charts are actually calibrated not for 1 mm, they are calibrated for 1 centimeter. So that's the difference. So if you use either a servo gauge or if you use either a radar gauge, that plus minus 10 mm accuracy is good enough for you as a user. But here radars can give you accuracy of 1 mm. That's a documented fact. So don't worry about that the accuracy, because I see and I hear these kind of the questions coming up from lot of users that servo gauge accuracy is very high and radar gauge accuracy is very less. But actually I tell you both are same. If servo gauge is not well maintained, you will see the accuracy going between 5 to 6 inches also. So that's a differentiator. So end of the day, it's how you maintain that machine or your instrument. That is the way it is going to work. Radar also gives you 1 mm accuracy. Servo gauge also gives you 1 mm accuracy. Both are giving you the same. But the differentiator is radars are not having any moving parts. So they are less maintenance prone. It's a non-contact level measurement. So you don't need to put any float. You don't need to put any sensors in between in the vessels. वो top पे रहेगा. You have the sensor on the top, and from the top the data goes on. That's it. Nothing else. So you don't need any still well. You don't need any vessel modification. So no need of PESO approvals. That's the beauty. You just install a radar on the top of the nozzle. Nozzle can be 1 inches also. So we have radars which can be actually installed on half inches also. But for LPG, we have seen minimum 1 inches or 1.5 inches nozzles are always available. So we recommend that you should be installing these radars on 1 inches nozzle. These are maintenance free because we do not have any kind of electronics, any kind of electromechanical devices into this. So these are excellent choice for above ground bullets. Do you agree on this? Okay. I see. There are different opinions. You must be having a lot of difference, but I really respect that. This is my opinion, and this is what I have thought of. Now we can now discuss about the deficiency of radar also, because we spoke about the deficiency of the servo gauges. Now the deficiency of radar gauges can also be discussed. Yeah. First of all, radar gauges don't have a vapor composition. This is something which has not been brought out by any of the radar vendors till date. The reason being is everyone wants to sell a radar, but radar has not got any vapor composition in it because it's just sending the data, and waves are just coming back. But the density of the vapor sometimes affects that. The density of the vapors affects that because normally radar is calibrated in air where there is no vapor, but as soon as the vapor comes the density changes, and the waves will actually have some issue. So to overcome this, what we do is we basically use external temperature and pressure compensation over there, so that we have inbuilt. So we put a radar and we have a standard temperature and pressure sensors with the radar. So we know that what is the particular density of the vapor there. So based on that, we do the compensation and we calculate everything over there. Second is radar, since although they are non-contact instruments, but they need to be on the nozzle. The nozzle has to be open so that the waves can pass through. So if you have a nozzle which is having a blind, or you have a nozzle which is having just a basic gate wall, you just cannot install the radars. You need to have a very clean path for the radar because the waves can pass through only very cleanly, otherwise they will not be in a position to pass. So what we do is we provide a ball wall, full bore ball wall has to be installed on the radar, only then it is going to work. Now here, in case that ball wall is not there, or you don't have a proper valve over there which can have a full pass through, then we need to degas the vessel. This is also one of the cumbersome activities for the LPG plant, because I know you will have to take a shutdown, you will have to take internal approvals also to degas it. It's not so easy job. So depending on the location that you are degassing, you need water also and all those things. So but for this particular application, you need to degas sometimes. It's hardly 10% of the cases, because we have seen most of the people using ball walls on the 40 mm nozzle, which are already there for your pressure measurement and all those things. So we can install radar on that directly. So in my experience, we have never gone for a degassing of the vessel because the wall was already there. But in case there is no wall, then we may have to go for a degassing of the vessel. So this is one of the challenges that we have in the radar gauges. Still, it's an excellent choice for the work bullets. Hope you agree. Okay. Now, coming to this, now I want to introduce you to a very revolutionary new technology for above ground bullets, where in the servo you have a challenge where you need to have a nozzle which is of 8 inches minimum. And if you don't have that in the above ground bullet, you need to go for a vessel modification. So that's also a cumbersome process. For radar gauges, you need to have a minimum nozzle size of 1 inches, 40 mm, 2 inches. That is the minimum requirement. But you may have to go for a DES. That's a challenge. Now, if I tell you something, if I introduce you to a new technology where I tell you, you don't need a nozzle, you don't need to degas the vessel. In fact, you don't need to, I would say, put your vessel into shutdown mode also. The level gauge can be installed during the operation of the tank. Will it be a good advantage for you? Okay, great. So I'm pleased to introduce you a new technology which is already being tested in the LPG industry across the globe, including India and IOCL, various locations for particularly for LPG. That's called truly non-invasive level gauge. Now this is the gauge, how it looks like. What it does is it's basically non-invasive gauge. As I said, you don't need a nozzle on the top. You just don't need any kind of valve on the top. You don't need any still well. This sensor never comes in contact with the LPG. This is the beauty. So I'll just show you the operating mechanism. If you see, this is a bullet, it's a standard bullet, and the sensor is actually bonded onto the bottom of the vessel. So if you see, this is a standard sensor, and the sensor size is very small. It will be like a small cup, even smaller than this cup itself. So it's a very small sensor that we have. So based on this, you can see you are not installing it on the top of the vessel as a nozzle. You are just bonding it on the bottom. So ये bottom में चिपक जाता है. You just bond it with adhesive, Loctite or something like that, and based on that, you are able to give some kind of output. So it works the way the radar works, but radar actually works from the top to bottom. Here it works from the bottom to top. So what it does is it sends the wave from the bottom via the walls of the vessel, and it crosses the vessel's wall, and then they go directly to the liquid level, highest interface level. And whenever there is an interface level, when the waves move from denser to lighter medium, or lighter to denser, there is a refraction going on. So as soon as there is a reflection going on, that reflection is being measured by this sensor. So these sensors can calculate how much these waves have traveled in the LPG, and from there it has come back. So it calculates and tell you what is the distance of LPG. This is the direct measurement of LPG from here. That is one. Second thing is, now your question will be, the density of the LPG is going to change with the temperature, because that's a valid question. Here the accuracy has been maintained by the same principle. We have got the sensor, when it bonds to the bottom of the vessel, it also measures the temperature, and not the temperature of the surface. Although it is measuring the temperature, but it has got the algorithm inbuilt. When you feed MOC of the tank, the thickness of the tank, and the media inside the tank, it automatically calculates how much is the temperature inside the vessel. So based on that, it compensates for that to give you an output where you are able to measure a proper level of LPG. So this is something which is a revolutionary product, which we have already been giving to Indian Oil, LPG across the country. Even the refineries are also using it. This can save lot of hard work for you, where you are not having enough size of nozzle on the top of vessel. You are not having possibility of putting still well in the vessel. You are not having a possibility of taking a long shutdown for the modification of the vessel. So this is the principle that you can use and install on this. So what are the benefits? It's fast and reliable. Just लगाएं और measurement कीजिए. You will just simply, we get the reading within 30 minutes. No shutdown, nothing. Just install it. You don't have to open the tank. You don't have to do any cutting, welding, drilling on the tank. You can install it when the tank is operations. There are no moving parts. This is an excellent choice for above ground bullets. Gentlemen, I would request that you should definitely have a look at this product. This product is available as a free demo by us. If you are looking to go for any kind of level gauge on your above ground bullets, this is the sensor that you should go in for, along with the radar gauges that we have. Forget about the servo gauges, because servo gauges are now tradition. So let's forget about it. Let's put two gauges, which are radar gauges and non-invasive level gauges. Both the gauges will work in tandem with each other and are going to take care of your inventory successfully. Now, what I'm going to do is I'm going to have a summary of all the three technologies that we have discussed. So, first technology that we discussed was servo gauges. Now, servo gauges, they need minimum 6 to 8 inches of nozzle. So, above ground bullets, forget about going for it, because there are no nozzles free of 6 and 8 inches. So, in case you want to install a servo over there, you will have to go for a vessel modification, because you will need to put a new nozzle, you will need to put a new support structure for the servo, and you have to put a still well also. So, all the three activities will take time, money, everything, as well as your PESO approval, plus the safety part. So, because if you are going to maintain a new vessel, or you are going to do a maintenance on a new vessel, that vessel will not be available to you for next 6 months. So, you have to see to that you are having that much of time spare with you, so that we can. Plus, after COVID, the PESO is also taking its own time because of the staff crunch and the meeting crunch. The basic approvals are also taking a lot of time. So this is something which I wanted to share with you. Second type of the gauge that we have is radar gauge. This needs degassing, but yes, degassing I understand for above ground villages may take 2 days or 3 days. So you have to take a shutdown of 2 days or 3 days. That's it. but you can go with the radar gauges very easily. Nothing to worry about that, because radar gauges can be installed on a standard your pressure nozzle, which is of 40 mm. So on a standard 40 mm, we have got many references of radar gauges working very successfully on 40 mm nozzles across the country on LPG, on difficult applications like Horton sphere, on mounted bullets and above ground bullets. We have done all the three type of application on 40 mm size. They work perfectly all right, give the accuracy of 1 mm. It is acceptable. Last, not the least, is non-invasive gauges, which I request you to kindly consider because it fits 99% of the applications in LPG. You don't have to worry about it. Wherever you have a LPG storage vessel, just go and install it. And one thing more, we have this on ready demo for you. So in case any of you want to install it on your vessels, please get in touch with me. We can provide a free demo to you as soon as possible. So this is our brief of our team. We have a team of 30 plus engineers, where myself, my name is Manmeet Singh Bhatti. I have got more than 25 plus years of experience purely and purely instrumentation and control. My team members, Mr. Tilakraj Suman, Inderpreet Singh, Vipin Bali, they have got more than 25 plus years purely and purely into instrumentation and automation. So we are a company who has been breathing industrial automation from last many years, and we have done successful projects for the LPG across the country. Please allow us to work with you, to help you to have your systems managed, inventory managed at a centralized place with high accuracy. To know more about our company, you can visit advancedengineers.com, or we have a dedicated site for LPG, that is lpgsensors.com. You can go and visit that also, or you can get in touch with me. My number is here on the video. You can get in touch with me as soon as required. I will get back to you for any kind of the demo, any kind of the detailed applications. Thank you very much. Bye bye.